Welcome, algebra students. Today we're going to be doing an Edpuzzle covering sections 921 and 922, which is solving inequalities in two variables. So last week you talked about solving variables or solving inequalities in one variable. This is going to be in two variables. Okay, so these notes that I have in front of me right now, these are in Google Classroom, and you're welcome to print these and follow along as we go or take notes on a separate sheet of paper. It is important, though, that you take notes. Depending on how you do on your Edpuzzle, you may be asked to submit your notes. Okay, so it's just a good idea to have those to refer to. Again, these notes do not need to be submitted. There are a couple of links and graphs we're going to be looking at, and you'll notice that they are hot linked in that presentation. So you might even want to just pull them up so that you can have the graphs to look at. Okay, so let's get started. So last week, you learned how to use an inequality with one variable to help solve a word problem. You also discovered that a one variable inequality can have 0, 1, or more solutions, and that these solutions can be represented on a number line. But what if an inequality has two variables? That's what we're going to talk about today. What is the solution to a two variable inequality, and how could these solutions be represented graphically? So we're going to take a look at the graph of y equals negative 2x plus, this should be a 3 actually. Okay, and that was actually part of your assignment that you were supposed to do last week. So the question is, are these following points a solution to this equation? So think about, how would we be able to figure that out? Okay. So what we could do is we could substitute the points into our equation and see if they make them true or false. All right, so let's do that. I could put, this is an x and a y. I could put 5 in for y. I could put negative 1 in here for x. And see, I'm going to put a question mark here, is the left side equal to the right side? So here I would have 5 equals 2 plus 3, and 5 equals 5. So it's a solution. Okay, and then we could do that for each of the following. Okay, so you're going to do that. I'm going to have you answer those questions via Edpuzzle. Okay, so now what we want to do is we want to actually look at this graph, and we want to know what determines if a point is on a line. So what I'm going to do is I'm going to show you the graph with these 4 points plotted, and I want you to have this question going in the back of your mind: what determines if a point lies on the line? And then from there, I'm going to ask you a question in Edpuzzle, so make sure you're thinking about it. So just a quick check: is this ended up being a solution? This ended up being a solution. These two were not solutions. Okay, so as we look at the graph, we want to keep that question in mind. So two things really: what determines if a point lies on the line, and then what's the difference between the points on the line and the points not on the line? Again, these are going to be Edpuzzle questions in a second, so you want to make sure that you're paying attention right now. Okay, we want to look at this graph. Okay, so here's my graph, and what I'm going to do is I'm going to plot these points. So I'm going to plot the point negative 1, 5. And so there's a point negative 1, 5. All right, and now let's see. Remember, that was a solution. Now let's plot the point 2, negative 1. And remember, that point was a solution. So remember, what determines if a point is on the line? You should be asking yourself that question right now. All right, so now let's put in the 0, 0. That did not make our equation true. And let's put in that fourth point, the 0, negative 3, and see what happens there. Okay, so again, you should be thinking about that question. What's the difference between the points that are on the line and the points that are not on the line? Okay. Hopefully you notice that the points that are on the line, those were solutions, and the points that aren't on the line are not solutions. Okay, so that's in general when you have an equation with two variables. Any of the xy pairs that make that equation true fall on the line, and anything that doesn't won't. Okay, so now let's look at this next one. So in number 65, we just found that the points on the line are the only points that make the equation y equals negative 2x plus 3 true. But what if you want to graph the solutions for the inequality y equals negative 2x plus 3? That's what we're going to look at next. So how will that graph be different from the equation? So we're going to start out the same way, and we're going to think, okay, which of the following are solutions of the inequality? We'll do the first couple together, and then I'm going to give you Edpuzzle questions to check the other three. So please make sure that you're paying attention so that you're able to do those correctly. Okay, so for this first one, same idea as above. I'm going to substitute now into an inequality. So I'm going to have y is bigger than or equal to negative 2 times negative 1 plus 3. I'm putting a question mark there because I'm not sure if that's going to be true or not. So then I have 6, and I want to know, is that greater than or equal to 2 plus 3? And is 6 bigger than or equal to 5? It is. Okay, so that means that this is a solution. All right, now let's try this next one. Maybe pause and try this on your own first. So I'll have 2, and I want to know, is that greater than or equal to negative 2 times negative 2 plus 3? So I'll have 2 is bigger than or equal to 4 plus 3. Okay, is 2 bigger than or equal to 4 plus 3? Is it bigger than or equal to 7? No, so this is not a solution. Okay, these three are going to come up right now as Edpuzzle questions for you to answer. Okay, so as you went through that process, all three of these actually ended up being solutions. And what we're going to do next is we're going to look at our graph. Now, when we look at the graph, I put a bunch more points. So had we been in class, I would have given each of you like 2 points, and I would have given you the inequality, and I would have asked you to check if they were solutions, and then we would have come up to the board and we would have put the ones that are solutions up, and then we would make notes of the ones that are not solutions, and we would kind of look and see what patterns we notice. So because we're not together, I took a bunch of points, I put them on the graph. On the graph, anything that's green was a solution to the inequality, meaning if I plugged it into the inequality, it would be a true statement. All the ones in red are not solutions to our inequality. So let's take a look at the graph. And as we're looking at the graph, we want to keep these 4 questions in mind because I'm going to ask these to you as Edpuzzle questions in just a minute after we looked at the graph. So we want to think about, what do we notice about the green points that are solutions to the inequality? What are you noticing about where they're located on the graph? You might want to take some notes on this as you're looking at the graph, because like I said, I'm going to ask you these questions. Do you think these are the only possible solutions to the inequality? Why or why not? And in the Edpuzzle question, make sure that you're giving an explanation, otherwise you will be marked wrong. Okay, how many solutions do you think there are to this inequality? And then why aren't any of the points below the line a solution to the inequality? Okay, so let's take a look at this graph. This one right here. Okay. Oh my goodness, you guys. It didn't save it the way I wanted to. Okay, so really quickly, I'm going to go through and change the colors on these. I'm really annoyed because I had gone through and changed them to the color that I wanted them to be. And now they are not that color. Okay, so I'm going to make my line black. All right, so as we go through, like I said, I picked a bunch of different lines. And so the point negative 1, 2, if I plugged it in, would not be a solution. The point negative 1, 6 would be a solution. The point negative 2, 2, if I plugged it in, would not be a solution. The point 2, 7 would be a solution. The point 2, 4 would be a solution. So annoyed that this didn't save the way I wanted to. Okay, the point 1, negative 3 would not be a solution. The point negative 1, 1 would not be a solution. So as I'm going through these guys, the ones that are solutions, I'm turning green, and the ones that are not, I am turning red. And I want you to be thinking about what patterns you're noticing, okay, about where the solutions are compared to the ones that are not solutions. So what patterns are you guys noticing? Okay. I know this is taking a long time, and I'm really sorry about that. All right. So hopefully what you're noticing is, let me finish this. Okay, so here we've got them correct now. Oh, negative 1, 5 is a solution. Okay, so I'm going to ask you some questions here in a second. My questions, again, are going to be, what do you notice about where the green dots are? Do you think these are the only solutions? How many solutions do you think there are? And why aren't there any solutions below the line? Okay, so you should be noticing you've got green dots, right, and red dots. Okay, so you're going to answer those questions for me. Okay, so hopefully what you noticed was that all the green dots are up here above the line and all the non-solutions are here below the line. Okay, if it's on the line, we know it's also a solution. So then the answer to the question is, do you think that these are the only solutions? Are there any other points up here that you could plug in and have them be true? Anything up here would make it true. Anything below the line is not a solution. So when I ask what's the number of solutions there are, and the answer is there are infinitely many solutions. In fact, if I were to change my equation here to an inequality and make this greater than or equal to, notice what happens. Everything above the line is shaded, indicating that all of the points above the line are solutions. Okay? So that's kind of what we want to be thinking about as we're graphing inequalities. It's going to be that we have a line, but then we're going to shade on either side of the line, wherever all the solutions fall. Okay, so now moving on, and then we'll do some practice. Right, now, what if the graph were shaded to look like this? What inequality would correspond to this graph? Okay, so first, the equation for the line. I notice I have a y-intercept at 3. Okay, so when I go to write, if it was just the line I was thinking about, it would be y equals mx plus b. And I know the b value is 3. And then what's my slope? So to get from one point to another, so to get from, let's say, that point to this point, I go down and I go to the left, so down 2 over 1. So really, it's the same line as I was just looking at, except for it's everything below. Right? Remember, those were non-solutions before. But if I change my inequality to less than or equal to, then it would be that graph that I'm looking at there. Okay, now, here's another question I'm going to ask you. How do you think the graph would be different if the inequality changed to y is less than negative 2x plus 3? So what is the difference going to be between less than or equal to and less than? And maybe think back to what was the difference when we were graphing on a number line between like a less than and a less than or equal to. Okay, so let's actually take a look at it here. Let's go back to our Desmos and let's change this. First, we're going to change it to less than or equal to. Okay, so that's that shaded graph we were just looking at it. And so now you can see everything that wasn't a solution before now is a solution. And if I were to make it just a less than and not a less than or equal to, notice how it changes. Instead of having an open circle like we did before, now we have a dashed line. So remember when we were graphing on a number line, it was either open circle or a closed circle. Now it's the difference between a solid line and a dashed line. All right, so now let's do some practice. So when we're graphing an inequality in two variables, here's what we're going to do. So the first thing we're going to do is we're going to graph the boundary line as though it were an equation. Okay, the difference is going to be if it is a less than or equal to or a greater than or equal to, we'll have a solid line. And if it's a less than or greater than, we will have a dashed line. Okay, we will shade the region that makes the inequality true. So to do that, what we're going to do is we're going to test points sort of like we did when it was a single variable, and we're going to shade on the side where it's true. Okay, so we'll choose a point not on the boundary line and substitute the ordered pair into the inequality. If the inequality is true, we'll shade on that side of the boundary line. That's where the side where that test point is. And if it's false, we shade basically on the other side. Okay, so let's take a look at these inequalities here. Whenever I print, my grid doesn't show up. So I'm going to do my graphs on graph paper rather than on this paper here because my grids never show up. Okay, so this is an equation for a line. So I'm going to start out just by graphing y equals negative 1/3 x minus 1. Okay, so that's my boundary line. And that's sort of like what we did when we solved inequalities. We solved it as though it were an equation first. And this here tells me that I'm going to have a dashed line, right? It's greater than that line, not actually including that line. So the greater than the dashed line is just showing it's everything up to that line, but not actually including that line. Okay, so now I have to use everything I learned way back in chapter 2 or 3. I don't even remember anymore. It's been so long about how to graph a line, right? Here's my slope. Here's my y-intercept. So we always start at our y-intercept, which is negative 1. And in this case, my slope is negative 1/3. That's my rise and my run, right? That's my change in y over my change in x. So from here, I'm going to go down 1 and I'm going to go to the right 3. And I'm going to do that a couple of times, down 1 to the right 3. I can also go up 1 to the left 3, up 1 to the left 3. Okay, I'm nervous, you guys, that I'm going to make a mistake and draw a solid line when it's supposed to be a dashed line just because we're in the habit of always doing solid lines. So I'm going to try really hard not to screw that up. Hopefully I won't. So we had said this should be a dashed line. Okay, so there's my dashed line. And now that's not it though, because I want to graph everything so that y is bigger than this. So it was y is bigger than negative 1/3 x minus 1. Okay, so what I'm going to do is I'm going to test a point on either side of the line. It does not matter which one. And I'm going to shade on the side depending on if it's true or false. So if my test point is true, I'm going to shade on that side. If it's not true, I'm going to shade on the other side. Now, if I can, I like to pick 0, 0 because it's really easy to plug in. But if my line goes through 0, 0, I will just have to pick something else. And it really doesn't matter what. So I'm going to test the point 0, 0. So into this inequality, I'm going to substitute 0 in for y, and I'm going to substitute 0 in for x, and I'm going to see if it's true or false. Okay, so is 0 bigger than, this would be what? 0 minus 1. So is 0 bigger than negative 1? That's true. Okay, here's the point 0, 0. Okay, if it's true, I'm going to shade on the side of the 0, 0. So I'm going to shade over here. Okay, you need to make sure you draw your line all the way through and that you shade all the way along. Okay, that whole thing is your solution. Okay, so when we're looking at your practice assignment on Thursday, we're looking to see that you've done the shading. Okay, if you haven't, you've eliminated an infinite number of solutions, so it's really important. Okay, so let's take a look at this next one. The first thing I want you to do is rethink of this as an equation. And I want you to solve that equation for y. That's the easiest way to graph it, is to get into slope-intercept form. This is going to be an Edpuzzle question. Really take your time, right? Solve this equation for y. Okay, so I would subtract my 2x, but then I still have this negative y over here, so I would have to divide everything by negative 1. So I have y equals 2x minus 5. So when I graph that, I know my slope is 2. Actually, I'm going to think of that as 2 over 1. So I have a change in y over a change in x. And my y-intercept is negative 5. Okay, so I'm going to plot that line. Graph that line up. And we should also be thinking about, okay, solid or dashed, right? This has the equal to underneath it. That means solid. Okay, so y-intercept 1, 2, 3, 4, 5. And my slope was 2 over 1, so that's a rise of 2 and a run of 1, or a change in y of 2, change of x of 1. Okay, we set a solid line. I left all my rulers at Berkeley High School, so I don't have one right now. Okay, and then we need to test a point. Again, my line doesn't go through 0, 0. I'm going to pick 0, 0, right? And I'm going to see if that makes my line true or false. So if I put 0, 0 in, and really you guys could put it in your, you just put it in your original, right? Because this we took the inequalities out of. Okay, so I'd have 2 times 0 minus 0 is less than or equal to 5. So that would be 0. Is 0 less than or equal to 5? It is. So I want to shade on the side with the 0, 0. Okay, so this is my solution. Okay. Now, some of you might have been thinking, well, hang on, that's a less than or equal to, and that doesn't make any sense. It should be below. Because if you look over at this one, right, it was a greater than, and we shaded above. Okay. That rule will work sometimes, but not always. And what that has to do with is this dividing by a negative, switching up the direction of the inequality. So that your safest bet to make sure you're shading correctly, and this was the case with the number lines also, is just to test a point. Okay. All right. So we're going to graph a few more because, and this kind of gets into the 9-2-1 part, 9-2-2 versus the 9-2-1, is that this works not just with lines, but also with exponentials and quadratics, things that we have graphed in the past. So we're going to look at a couple of those. So this first one, what type of function is this? Is it a line? Is it going to be exponential? Is it going to be quadratic? What shape do you think this is going to have? Okay, so you should be saying, oh, that looks like y equals a times b to the x. That's exponential. I notice that 1.15 is bigger than 1. That's exponential growth. Okay? This is my y-intercept. That's my start value. Okay, so you might be saying, all right, well, I know that thing starts at 4 on the y-axis. And then you could just plug in 2 or 3 or something like that, right? And then get your second point and then graph it. All right, so here I'm noticing that this is a less than. It's going to be dashed. And so I'm going to plot these points. I'm going to plot the point 0, 4, because I know that's my y-intercept. And then let's see what happens when I plug 2 in. So I'm going to just pop over to Desmos really quickly here. And I'm just going to type that in just to see what I end up getting. Okay, so if I just do 4 and then I do, whoops, not the letter Z, 1.15, and then I do it to the, let's say, second power, I get 5.29. So I'm going to graph 2, 5.29. So I'm going to have the point 1, 2, 3, 0, 4, and the point 2, 5.29. And then I know it's exponential, so it curves. Sorry, I'm plotting it. You can't see. Okay, so those are my 2 points, the 0, 4, and the 2, 5.29. And I know it curves because it's exponential, and we said it would be dashed. Okay, and then we want to pick a point and test it and see which side we should shade on. So again, my 0, 0 is not part of my line. And so I'm going to test the point 0, 0 again. So I'm checking, is 0 less than 4 times 1.15 to the 0 power? Okay, so that's 0 is less than 4. Remember, anything to the 0 power is 1. Is 0 less than 4? It is. Okay, so we're going to shade below the curve. Okay, so it's the same idea, but the graph is curved instead of just being a line. Okay, let's take a look at this next one. Again, I want you to think about, well, what is this going to be? Is it going to be a line? Is it going to be exponential? Is it going to be, is it quadratic? Is it going to give me a parabola? Okay, so hopefully you're looking at that and you're saying, oh, I see this squared. It's a parabola. What form is this in? Is this in graphing form, like vertex form, or is this in intercept form? What can you tell really easily right now? Can you tell what the vertex is, or can you tell what the x-intercepts are? Okay, hopefully you notice that that's in vertex form. So we know our vertex is HK, so that would be 6 3/4. And I'm sure you're all saying, great, a fraction, my favorite. Okay, so I know my vertex is 6 3/4. Usually what we would do from here is I'm going to imagine this were an equation versus an inequality. And what we would do is we would set it equal to 0 to find the intercepts, right? The intercepts are when y is 0. And I would subtract this 3/4. And then I have to get rid of this 1/4, so we would multiply by 4. And you might be saying, uh-oh, I'm getting a negative. And if I take the square root of a negative, it's not possible. I can't find any x-intercepts. Well, this actually does not have any x-intercepts. So if I plot 1, 2, 3, 4, 5, 6, and 3/4 is right here, And I know it opens up. Well, that makes sense. It doesn't have any x-intercepts. So what I could do to get another point on this graph, because it doesn't have any x-intercepts, is I could just do a quick little table. And if I know my vertex is 6, I could just pick an x value on either side of the 6. Let's say I pick 7. And if I plug that 7 in here, so I have 1/4 times 7 minus 6 squared plus 3/4. Well, that's just 1 squared. And 1/4 plus 3/4 is 1. So I have the point 7, 1. And because I have symmetry in a parabola, I can just plot another point on the other side. Now, what is this supposed to be? Solid or dashed? Solid. Okay, so I have a solid parabola, and then I want to see on which side should I shade. Okay, again, 0, 0 is not included, so I'm going to check the point 0, 0. So I'm going to do 0, is that bigger than 1/4 times 0 minus 6 squared plus 3/4? Okay, so then I have 0, is that greater than or equal to 1/4 times, that would be 6 squared, so 36 plus 3/4? Well, I can just look at this and tell 0 is not going to be bigger than that because that's a positive number. I mean, I could go through and say, okay, that's 9 3/4. So this is 0 bigger than or equal to 9.75? No, 0 actually here, we have one, is not a solution. So if 0 is not a solution, we're not going to shade over here. We're actually going to shade in here. Okay, so if this keeps going and this keeps going, my shading is inside my parabola versus outside of my parabola. All right, a couple more. This one, x is less than 2. Now, sometimes people freak out when they see this. They're like, oh my gosh, what do I do? There's not enough information. It's actually just a really quick one. So if x is 2, remember that means there's no y-intercept. It just is that x is always 2. The x-intercept is 2, and it never hits the y-axis at all. So remember, if it's just x equals 2, it's just a vertical line through 2. And because this is a less than, it's going to be dashed. Okay, and then we want to pick a point and shade on the side that, if it's true, shade on that side or shade on the other side. 0, 0 doesn't go through my line. Okay, so I'm going to pick 0, 0 again, and I'm going to substitute it in here. Now, x is 0, less than 2. I have nowhere to put that 0, but that's okay. I'm just going to plug in what I have. Okay, is 0 less than 2? Yeah, it is. So I'm going to shade on the side of this line that includes the 0, 0. Okay, so it's just now a vertical line, and in this case, everything to the left. All right, our last one. Again, I want you to look at that and think, is this quadratic? Is it a line? Is it exponential? Okay, so hopefully you're noticing it's quadratic. And what do you think would be easier? Would you rather get it in graphing form by finding the vertex? Would you rather try to factor it and find the intercept form? Really, this could go either way. I think you could do completing the square or not, or you could factor it. I am going to factor it just quickly here. I know this factors into x minus 3 times x minus 1. And so I know my x-intercepts are at 3, 0 and at 1, 0. Okay, so on my graph at 1, 0 and at 3, 0. That means my vertex is somewhere along. I know my vertex is 2 something, right? Because my vertex is halfway between. And so to figure out what my y value is, I'm just going to plug the 2 in up here. So to get this y value, I'm going to do 2 minus 3 times 2 minus 1. That's going to give me my y value. So that's negative 1 times 1, which is negative 1. So here's my vertex at 2, negative 1. This is how we're going to graph this. This is going to be dashed. I'm really proud of myself. I think I didn't screw that up, hopefully. Here's my dashed curve. And then for the shading, I'm going to think again. All right, I need to pick a point, 0, 0, I can use again, and I'm going to plug 0 in for x and y. I could do that in this equation or my one here that's factored. I'm going to just go ahead and put it into my original. So 0 is less than 0 squared minus 4 times 0 plus 3. So 0 is less than 3. Okay, that's true. So now I want to shade on the side that contains the 0, 0, which would be everything now outside of the parabola. Okay, Take care, algebra students. I'm sorry it was such a long video.